Hello, my name is Harry Crocker, and I'm excited to share with you my project on DFX, where I take a deep dive into improving a camera. The personal product that I look to improve is this Fujifilm X-T20. This is a mirrorless camera which is great for travel photography. It's famous for its X-Trans CMOS sensor and has 24 megapixels. One of the limitations that I've found when using this camera is this lens cap, which is used to protect the very delicate glass lens. Now, this is a separate piece that is easily lost, and it's also very slippery and has no ergonomic grip. This is also quite a cheap design on a very premium product, which takes away from its overall appearance. To attack this problem, I first went through the ideation phase and came up with some concepts for how I might be able to protect this lens while having one part which stays on the camera permanently. I was inspired by the aperture mechanisms inside of cameras and also called iris mechanisms, where there are several wings which come together in a circular motion to close and fully protect the lens. Here's the solution that I came up with. It is mounted to the Fujifilm camera permanently, and the dark gray ring can be rotated to move the light gray wings out of the way when you're taking a photo, and then is easily rotated back to protect the lens when the camera is not in use and you're on the go. Here's a closer look at how the iris mechanism functions. On the left is the closed configuration when the lens is protected. Then, when you half turn the ring, you reach this intermediate stage, and then when it is fully turned, the shutter is completely open and you are able to take a photo clearly. This is a very smooth process and a very robust mechanism, which is essential for all photographers to be able to open and close this quickly, as you never know when that perfect photo might come up. This is a very premium and designed for human factors to enable these customers to really interact with this product well and be able to not have it interrupt their artistic workflow. Looking at the components that make up this mechanism, there is a dark gray ring, which is a rubber ergonomic textured grip, which allows the user to interface with this product very well. Then there are the light gray moving shutter wings, which close and open in a rotating motion to allow the user to take a photo. You can see on the rear view the black arms which move the shutters out of the way when the ring is rotated. This is a minimalistic design which aids its portability and fits within the form factor of the camera very well to not take away from its overall well-designed appearance. The materials used are a ABS plastic for the shutter wings and rotating ring. One has a glossy surface finish and the other has a matte surface finish, and then a TPU rubber overmold on the ring to give it to improve the user experience and allow them to grip it much more easily, unlike the previous solution, which is just all plastic. There are also stainless steel little dowel pins for the rotating components. And stainless steel was chosen as it is very corrosion resistant, as these cameras are often taken outside and are exposed to the elements. Some of the advantages of this product are that it is small and portable. This permanently stays on the camera, which stops it from getting lost easily, unlike the previous design. It also has an ergonomic rubber grip, which helps the user rotate this mechanism very smoothly. One of the potential disadvantages is that the shutter wings could get caught on something when it is in its open position. However, I doubt this will be a major issue, as when it is in its open configuration, you are usually taking a photo, and when it is stored, it is usually closed. Another benefit is that this product is not just limited to this camera. It can be scaled across all cameras in the industry. This is a massive market share and a lot of potential for this product. In order to produce this product at scale and take advantage of all of the potential out there, a very robust manufacturing process will need to be put in place. The very first step will be to create the molds which make these injection molded plastic parts. These will need to be very high quality steel molds to last a very long number of cycles. Then the injection molding equipment will need to be sourced. And then finally, the whole assembly line can be constructed with cobots, which are able to work together and quickly produce these products to create the high volumes to meet the potentially large demand for this product. Here's a closer look at how the injection molding process works. First, the pellets are put into this mechanism, which heats it up, and then a worm screw pushes that molten plastic into a mold. Then, from there, the mold is opened up, and the ejector pins push the part out into a bucket where it is collected. This is a very fast process, which is frequently used for high volume plastic components. Then on the right there is a table of the different finishing types that can be used on plastic injection molded parts. One will have a glossy finish and one of the other components will have a matte finish. Some of the considerations that went into the DFM for this injection molded part were draft angles to allow it to be ejected from the mold easily. Also, constant wall thickness, which avoids uneven cooling, which creates porosity and dimples in the final part. Also, there are no undercuts, which would make it difficult to eject the mold from the part and would need a slider or a second piece in the mold as well, which makes it much more complicated. Also, the ejector pin placement would need to be laid out as well as a mold flow analysis as shown in this GIF to make sure the plastic flows through the mold easily. Here are the resources that I used for this project. Thank you for watching, and I hope you enjoyed learning about this innovative product that will transform the way humans interact with their cameras and are able to take photos on the fly.